Hi there, welcome to PCM. In this video, we will be studying about a function named greatest integer function. It is not really a topic of class 11th or 12th, but it is generally useful to know this function and what it does. Okay, so first it is notated as this square bracket of x, or can be written as this thing. It is just a matter of notation. You can denote any of these, but generally this one is preferred. Okay, so what does this mean? It means that this function will return a value that is greatest integer less than or equal to x. Okay, so it will return a integer, greatest integer less than or equal to x. So let us take an example. If we have to take an example, box, it can be said as box function. Okay, so it names are box function, step function, or greatest integer function, or I prefer calling it gent function because it is easy for me. Okay, so if I have to say gent of 1.6, it is equal to 1, because 1 is the greatest integer that is less than or equal to 1.6. So if this is the number line, here is 1, here is 0, and here is 2, then somewhere here is 1.6. So we have to take this area and go from this side until the first integer strikes. So 1 is the answer in this case. If we have to say that 0.8, then it will be 8, then it will be 0, because 0.8 will be somewhere here, then we go here, then 0 will be the first greatest integer. Okay, so if we have to say that 2.3, then it will be just 2, because 2.2 is the greatest integer less than or equal to 2.3. But if we say gent of 3, then it would be 3, because 3 is itself an integer. Also 3 is less than equal to 3. So this equality comes in picture in the case of integers. Now we have to look at the case for negative ones. Suppose we see that gent of minus 1.6. What is gent of minus 1.6? So first, if we draw this number line, here it is 0, here it is minus 1, then here it is minus 2, then somewhat here will be minus 1.6. Now we have to choose. Now again we have to go to the left side of the number, then minus 2 comes in, the first integer that is less than equal to minus 1.6. so it is actually minus 2. If we have to say minus 0.8, then we have to say that it is minus 1, because minus 0.8 would be here, and if we go to left side, then minus 1 would strike on. It is 0, not 6. Then if we say gent of minus 2, then it will again be minus 2. Why? Because minus 2 is less than equal to 2. So this equality comes in picture for this case. Okay. Now we have to make a graph for this function. Okay. So if I draw this axis, so if this is y and this is x, let me mark points. If this is 1, this is 2, this is 3, and some points for the negative axis. Okay, so to number this would be 0, 1, 2, 3, 4, minus 1 and minus 2. Okay, so there is a very set way to draw a graph. Just start from 0. What is gent of 0? It is 0. So this point is there. What is gent of 0.1? It is again 0. And it will come 0 till 0.9, say 9999. Let's just say 0.999. It is again 0. But just 1, it will be 1. So for 1, it will be 1. So it will be 1. Till then it is 0, and gent of 1.1 is again 1, 1.2 is again 1, and it will till 1.9 will again 1. But the point you reach is 2, it becomes 2. So for 2 it will be 2, till then it will be 1. Okay, so here if I say I have to put this thing, because this means that it is not included, then we have to say this thing and so on. And in the negative side we have to say, so let us say 0.1 minus of, it will be minus 1. So this point is included here, then gent of minus 1 is minus 1. So let's just say this thing and draw it this way. Okay, and for the minus 2 case we have this thing minus 2 and this thing. Okay, so this is the graph of the greatest integer function, and it will be go on. So just to sum up, or just to note a few points about this function, we can see that this is a many to one function. What does this many to one means? It means that, take this case, for every value of x is equal to 1 or 1.1 or 1.2, 1.9, the answer is only 1. So for many values the answer is 1, hence it is a many to one function. Okay, so it is a many to one function. Now I will give you some points about this. So let us take some example, 2-3 examples only. So what is the gent of pi? It is 3. Why? Because we know that pi is approximately equal to 3.14. When we will be apply a box to it, gent of 3.14, it will become 3. Also remember that gent of x is always less than equal to x. It can never exceed x. The equality comes when x is actually an integer. When x is not an integer, then it is less than, but if x is an integer, then this equality comes. Okay, and if I have to say that gent of e, we know that e from the logarithm video, e is Napier's constant and its actual value is 2.71 approximate value, because it is an irrational number, we can't specify its actual value. So gent of e is actually 2, and so on. So if I have to say that gent of sine, trigonometric sine function of pi by say 3, this value will be 0. Why? Because we know that sine of pi by 3 is actually equal to root 3 by 2, which is less than 1. Also sine of x, gent, if x is less than pi by 2 or equal to 0, it will be 0. Why? Because we know that sine x is less than equal to 1 is greater than equal to 0 for x less than equal to pi by 2 and greater than equal to 0. This one is actually attained at x is equal to pi by 2, but this identity 0, this identity is true for x less than pi by 2 and greater than equal to 0. Hence if we take a box in this case, it will actually come to 0. So this function is used in some questions as a part of it and not as a complete question. And also note that whenever the question asks you to that this square bracket is used as a gent function, they will give you a clear indication that this is a gent function and not a simple bracket. So sometimes some student use this gent function instead of a square bracket. So just be careful. And in the next video, we will be doing a new function named fractional part function. And these two functions, greatest integer function and fractional part function, are sort of connected, and we will be learning about their connection. Till then, read on.